Alright, welcome back for another exciting day of Mrs. Northrop's notes. I want to make sure that when you are numbering our table of contents that it's matching up with the page number that we're putting our notes on. So if you're ahead or behind me in the notes on your pages, like if you ended up putting page 7 notes on page 8 or something, make sure that that's reflecting in your table of contents. Okay. Today's notes are going to be about parallel lines and angles. Okay. These are probably some of the most important angle relationships that we'll work with this year. They come up throughout the rest of the year whenever we talk about parallel lines. So our objective for today is the same one as last night. Determine and explain angle measure using unknown angle measure using a variety of theorems. Okay, I believe that was the same objective as the previous page. I'll just double check. Using a variety of, shouldn't be theorems, methods. Make sure I had that right. Methods. Okay, I believe we said that this was going to be page 11. And today's date is the 19th. In 3 more years, it'll be 9/19/19. That'll be kind of cool. All right, so the first thing we need to write down is something that I forgot yesterday, are adjacent angles. And they are two angles that share a ray. So all linear pairs are adjacent angles, but not all adjacent angles are linear pairs. So we could have, get my purple pen to denote that it's a diagram. We could have these two angles, angle 1 and angle 2, be adjacent to each other because they share this ray in the middle. And that's all it means, is that they're next to each other. Okay? All right. Next, I believe green was for theorems. Yes. Okay. And diagrams. But I like using purple. So we're going to use my green pen to write the parallel postulate. So Euclid never defined what parallel meant when he was writing about geometry in his book Euclid's Elements. But we surmise that what he meant parallel to be is that two lines having a transversal would not intersect if the angle formed between the lines on the interior of the lines was 180. So the parallel postulate says that if the sum of angles 1 and 2 are less than 180, the lines will intersect. Okay, and what that means is pretty much if the angles are supplementary, if they equal 180, the lines will not intersect. Okay, so we need a picture to go along with this. Okay, so here's my pair of lines. Here's angle 1 and angle 2. If these two angles right here on the interior of the two parallel lines add up to 180, lines L and M are parallel. So I denote L and M being parallel by writing this. L is parallel to M. Okay? And I can also denote them being parallel by using this notation. It's like a hash mark, but it's more like a little arrow. So two lines are parallel if I see this little hash mark on there. Okay? Now, there is a wide variety of consequences that comes from this. This line that passes through the two parallel lines, this line is called a transversal. And what it means to transverse is transverse means travel across. So this line travels across the two parallel lines, which is why we call it a transversal. Okay. So I'm going to draw a bigger picture of this because we're going to be using it more, right? To talk about some angles that arise and their resulting congruences and supplements. So I'm going to have these two parallel lines, and I'll mark them as parallel. Okay, and I'm going to number the angles starting at the top. Okay, and there are three important angle pairs, and there's two less important angle pairs. Okay, the first angle pair that we'll be talking about are same side interior angles. Okay, so same side interior angles are those angles 1 and 2 from the diagram up here that Euclid was talking about. So same side means they're on the same side of the transversal. So if I'm looking at 3, the other angle would be on the same side of the transversal. And interior means it's in between the two parallel lines. So the other angle that's on the same side of the transversal and in between the two parallel lines is 6. The other pair that's same side interior are 4 and 5. Okay? And same side interior angles are supplementary. If the lines are parallel. Okay, move that up. The next important set of angles are corresponding. And corresponding angles are sometimes hard for students to see. But here's the idea. If you took this little batch of angles up here, 1, 2, 3, 4, and slid it down the transversal so that it lands on 5, 6, 7, and 8, 1 would correspond with 5, 2 would correspond with 6, 4 would slide down and correspond with 8, and 3 would correspond with 7. So those are our 4 pairs of corresponding angles. So 1 and 5, 2 and 6, 4 and 8, 3 and 7 are congruent. So these angles are congruent, even look congruent, right? 2 and 6 look the same, 1 and 5 look the same, 4 and 8 look the same, 3 and 7 look the same. We never want to go by looks alone in geometry, but in this case it makes sense because they do look congruent. Are congruent if the lines are parallel. The next type of angles that we'll talk about are alternate interior. Okay. So alternate interior angles are on alternate sides of the transversal. That means one's going to be on this side of the transversal, one's going to be on this side of the transversal. So one on this side, one on this side. Interior means they're in between the two parallel lines. So I'm going to go in between the two parallel lines. So I can see where they are because alternate interior angles always kind of make a Z shape. So one set of alternate interior angles would be 4 and 6. And the other set, I'm going to use red so you can see the difference, would be 3 and 5. So there's that Z shape again. And congruent if the lines are parallel. So these angle relationships only exist if these two lines are parallel. Okay? If they're not parallel, none of this is true. Okay? Now there are a couple other angles pairs that we could figure out, but don't need to necessarily know the names. So some of the other ones are alternate exterior angles. So those are angles that are on opposite sides of the transversal and on the exterior part of the line, so they're outside the lines rather than inside the lines. So 2 and 8 are alternate exterior because they're on alternate sides of the transversal and they're outside the parallel lines. And 1 and 7 are alternate exterior because they're on opposite sides of the transversal and they're outside of the parallel lines. And they are congruent as well if the lines are parallel. Okay. The last pair of angles that we might talk about are same side exterior angles. So that would be like 2 and 7 and 1 and 8. And they're supplementary, but you don't really need to know those because you can figure those out using linear pairs and supplements. So I wouldn't worry too much about those. Make sure I touch on everything. So while this is all true if the lines are parallel, we can kind of go backwards with this as well. And we can say, and I'm going to do this on page 12, we can say if alternate, write this in black, sorry, if alternate interior angles are congruent, then the lines are parallel. So the converse of all of these angle relationships is true for parallel lines. So let me draw a picture here. So for example, I don't know that these two lines are parallel, but I do know that these two angles are congruent. Those two angles are alternate interior angles, and since I know they're congruent, I know the lines are parallel. Okay? I can say the same thing for corresponding angles. If corresponding angles are congruent, then the lines are parallel. So if I took a pair of corresponding angles, say this pair right here and this pair right here, so this angle and this angle, and I know that they're congruent, I know these lines are parallel. And the last one is if same side interior angles are supplementary, then the lines are parallel. Okay. So if these two angles right here add up to be 180, the lines are parallel. And that kind of goes back to Euclid's parallel postulate. And what is a postulate, I'm sure you're wondering, is just another way of saying theorem, but it's like a really, really, really important theorem, like super important. It's one of the 5 most important theorems that Euclid wrote. So it's one of the 5 most important things about geometry is the parallel postulate. So you can see which angles will end up being congruent. I'm going to go back to this diagram over here. Okay, 1 and 3 are congruent because they're vertical. 3 and 5 are congruent because they're alternate interior angles. 5 and 7 are congruent because they're vertical. So as you see, 1, 3, 5, and 7 always end up being congruent. 2 and 4 are congruent because they're vertical. 4 and 6 are congruent because they're alternate interior. And 6 and 8 are congruent because they're vertical. So 2, 4, 6, and 8 always end up being congruent. And if you can kind of memorize this diagram, it makes figuring out these things a lot easier. So I think I've hit almost 20 minutes. I'm going to stop. Enjoy. Have a nice night.